Hello everybody, welcome back. So today we're going to answer this question here. So where and why do volcanoes and earthquakes occur? So we're going to try to use some real-time earthquake data to analyze where most earthquakes occur and why this may be. So this is going to be within our plate tectonics unit, so there might be some sort of motion happening on the surface of the Earth that might be able to explain this. So first, before we move on any further, go ahead and pause the video. So I want you to quick jot this into your composition books. So where do most earthquakes occur in the United States? So in your composition, write down where that happens and why you think this may be. So, of course, it's okay to be wrong here. We haven't really learned about this in the class yet. So give it your best shot, see if you can figure it out. Alright, so I need you to get into Schoology now and get into this folder called Earthquake Patterns. So this has all of the resources that you are going to need for this activity. So go ahead and click on this Earthquake Patterns doc. So this was the handout that we gave in class today. So you have a digital copy here as well. So the first thing that we want to do is download some data. So all of your classmates, including yourself, are going to go to this website and download some earthquake data, right? So we have some data from last year's classes, so we're going to hopefully have over 600 to 800 pieces of data to make a map within Google My Maps. So if you go into the USGS website, you can download some data. So to go into latest earthquakes, and you can choose any on this map. So these little blips come up on the screen. So if we were to click on this one, that is a magnitude 3.8, and that was at Black Hawk, California. So once you pick a piece of data, so let's say I wanted to use that, we're going to go back in here and you're going to go into this Google form. So this Google form is going to be how you input your data. So you're going to put in the date of the earthquake, the location of the earthquake, so whatever it's called. So this earthquake is located at Black Hawk, California. They have the time that it happened, the location, and the depth. So within the Google form, I'm not going to do this for you, but you can put the location, so that'd be Black Hawk, the latitude, the longitude, the depth, and the magnitude of the earthquake. So once you input that and submit it, it will automatically be uploaded into a Google spreadsheet. So all of your classmates in real time, it's going to be continually updating a Google spreadsheet. So once you've done that, I want you to do 10 pieces of data apiece, so they're not difficult to find. Alright, so once you've done your 10 pieces of data, we can move on to actually making our map. So at this point, all of your classmates will have uploaded their data and it should have updated into our spreadsheet. So if you go back into the folder, we have this form here, which is Google Form Responses. Click on Form 1 Responses, and you can see all of the data that your classmates have put in. So if we click Form 1 Responses here, here should be all of your classmates' data. So try to pick some pieces of data that your classmates have not done, and let's see how many pieces of data we have currently. All right, so it looks like we have almost 800, we have about 718 pieces of data, so that is good enough for now. So this is how you actually make a My Map. So I have already downloaded this spreadsheet and uploaded as a CSV file. This is the only way that you can import a spreadsheet into Google My Maps. So click on that, and it brings us over to this page here. And this is how you download data. So this is all the pieces of data. You don't have to read that and give yourself a headache, but click this download button. So that gets downloaded into your downloads folder as a CSV file. Next thing we have to do, go into Google and Google My Maps. So this is different than Google Maps, but it's Google My Maps. So click in there, and whatever Google account you're signed in as, you can do this as. So go ahead and create yourself a new map. And we're going to title this Earthquake Patterns 2017. So last year's class did this, and we're going to do this as 2017. So click Save. So now we have a blank map of the world. And there's nothing fancy, there's nothing in it. So let's go ahead and import our data. So select the file from your computer, and you're going to go to Earthquake Patterns New, wherever that has gotten downloaded into your file. So you have your Chromebooks, it should be pretty easy. It should be in your Downloads folder. Alright, so this page comes up, and you're going to leave it as is. So So you want your place marks placed on the map with regards to latitude and longitude, so click continue. And for this, where they're getting titled, it's going to be the location of the earthquake. So once you have that, click finish. Alrighty, so now all of our pieces of data have been put into our world map, but they're all the same color. We don't know what this really means yet. So click dismiss here, go into uniform style, and we're going to group these points with regards to how deep these earthquakes are. So we're going to click depth here. Right, and now they're all rainbow colored and funky. So let's go into ranges, and we're going to do 2 ranges. So we're going to split these into deep earthquakes versus shallow. So remember, the focus of an earthquake is where that earthquake actually happens. So where is the break within the lithospheric plates? And then we're going to make this rainbow style like this, right? So now we've divided our earthquakes into 2 categories in regards to their depth. So the shallower earthquakes are going to be in red, and the deeper ones are in yellow. But we want to change the ranges. So if you highlight over this range here, you can click the paint button, and we're going to change this first one from 0 to 35 kilometers in depth. And for the second range, we're going to do 36 up to 672. All right, and now this is going to look the way we'd like it to. All right, so now if we zoom in here, all along this western coast of South America, there's a whole bunch of earthquakes here, all along here, and wow, look at the western part of the United States of America. This is where most earthquakes happen, and that's because there's a transform plate boundary here. There's a transform boundary which causes these earthquakes. But there are some anomalies here in Oklahoma. There's a whole bunch of earthquakes, but to our knowledge, there are no plate boundaries there. Those earthquakes are most likely caused by fracking out in the Midwest. There are plenty of articles out there for you to look up on, and that is mostly what's causing those earthquakes. So this is page 5 of your ESRT. So this shows us the tectonic plates, so the lithospheric plates that cover the Earth's surface and how they move. So if we look at our map, most of our earthquakes occurred along the western side of South America and the western side of North America, up along the Aleutian Trench, and most of our earthquakes occur along these boundaries, these plate boundaries. The reason for this being is when you have 2 plates kind of slide past each other, the stress between those plates overcome the friction, and once that happens, you get a release of energy, which is your earthquakes, which is the release of those waves. So this is a seismology graph, so seismic meaning earthquake, and these are all of the earthquakes within the last 6 years that have happened. So if you notice, we have them happening all along the Mid-Atlantic Ridge. We have them along this western part of North and South America, and all along here. So if we look back at our graph, this is where most of our plate boundaries are. So there is a correlation between where earthquakes happen and where plate boundaries occur. So this next map we're going to look at is volcanology, so volcanic activity. And there's still that same general trend. Along the western coast of South America and North America, we have a lot of volcanoes occurring, as well as our earthquakes. So if we flip quickly through these and look at our plate boundaries, that could be an explanation for us. So what's cool about this map also is that it shows the depth of our earthquakes. So if we just use our simple example, all along the western coast of North America, they're very shallow earthquakes. But when you move down to South America, there are some deep earthquakes happening within the coast here. So why is that happening? So if we look back at our ESRT, along the western coast of South America, we have a convergent boundary, and we have a subducting plate going underneath the continent of South America. But up here in North America, we have a fault. So this is a transform fault where 2 plates are sliding past each other. So there is no subduction happening. That is why there are not deep earthquakes over here. So looking at this map, along the west edge of South America, we have a subducting oceanic plate going underneath the continent of South America, causing these deep earthquakes. But while looking up here, we just have 2 plates kind of sliding past one another, so there is no subduction happening. There is not going to be deep earthquakes. So I hope you find success in making your own map, and I hope that you bring this in and you're excited about it, because we will talk about this more during class. Thank you for watching and have a great day.